This video is hypothesis testing for difference between two means. Learning outcome is constructing hypothesis testing for difference between two means when both n are greater than 30, while population means are unknown.
A very good day. Today we are going to continue hypothesis testing for difference between two mean. As last week we have seen how to do the hypothesis testing for single mean. So this is last week we have seen how to do hypothesis testing for single population means. Either use Z or T distribution depending on number of sample size. Similarly, today we are going to look at difference between two means. Also depend on Z or the T distribution depend on the number of sample size. Same thing, to perform the hypothesis testing for difference between two means, we still need to follow this 5 steps as in the hypothesis testing for single means. Where first step, write the original claim and identify whether it is a null or alternative hypothesis. Write down H null or the H node H1. Second step, use the alternative hypothesis to identify the type of test. Either write down by writing down all information from the problem and the specific case. State the distribution, either use Z or use a T distribution. Find the critical value, the alpha, based on the confidence interval given and the decision rule. What is the rules so that we can reject or do not reject the null hypothesis. Third step, compute the test statistic. Step 4, make a decision to reject or fail to reject or do not reject the null hypothesis. Step 5, write the conclusion. It's actually we are testing the mean of the population mu. Not testing the mean of the we are not testing the mean of the sample. We are testing about the population mu. If we knew the value of mu, then there would be nothing. If we knew the value of mu, then there would be nothing to test. So either for single population mean or difference between two means. So last week, we have seen this one. The decision rule for single means, the null hypothesis is always mu equal to 30. Now the decision rule for difference between two means, either, for example, mu1 minus mu2 equal to 30. Or we want to test whether there's any difference between these two mean, we may have mu1 minus mu2 equal to 0. Or other words mean mu1 equal to mu2. Here, mu equal to 30. Or we can have two populations, mean mu1 equal to mu2. Or they differ by a specific value, for example, in this case, 30. Versus alternative hypothesis, for single mean, you may have a H1 where the mu greater than 30, and then or left tail mu less than 30, two tails mu not equal to 30. So for mu greater than 30, you will reject H null when the Z test greater than Z critical, or the T test greater than T critical. And then for the this is for right tail, left tail will be reject H null when Z test or the T test less than negative of T critical. If two tail, we reject H null when the magnitude of the Z test greater than Z alpha over 2, or the Z test here replaced by the T T test and T critical. So similarly for hypothesis testing, for difference between two means, alternative hypothesis H1 may be mu1 minus mu2 greater than 30, or mu1 greater than mu2, or mu2 greater than mu1. Depend on the claim. So if mu1 minus mu2 greater than 30, we reject H null when the Z test greater than Z critical. Okay, and then the second choice for the alternative hypothesis will be mu1 minus mu2 less than 30. This is the left tail that will reject H0 when the Z test less than negative of Z critical. Okay, or mu1 minus mu2 not equal to 30. Then the rules will reject H0 when the magnitude of the Z test greater than Z alpha over 2. Similarly, the Z distribution or the Z test can be replaced by the T distributions. Okay, this is a single population mean. We have seen it last week. Number 2 also last week. 3. Okay, now today for the difference between two means. Okay, we got several cases here. Case A and B where the population means is known. And then case A where both sample size are greater and equal to 30 or both sample size less than 30. Okay. So as long as population variance is known, sample size bigger or greater and equal to 30 or less than 30, we use the Z test similar with for hypothesis testing for single means. Single mean is only we don't have the bar 2 and mu 2. Mean if single means you can delete the bar 2, the mu 2. So this formula, so the same thing. So the Z test will be, now you got two population. The sample mean of population different between sample mean of population 1 with population 2 minus with the difference between the population mean for the population mean for population 1 with the population mean for the population number 2. So this one, sigma is the variance of population 1 divided by number of site of population 1 plus variance of population 2 divided by number of site of population 2. So this case A and B. Mean variance is known. The variance known. C variance unknown. However, both sample size are greater than equal to 30. Then we still use even though now A and B population knowns we doesn't care about the sample size. We use a Z test. Since population variance known, we use a Z test with the population means second case the population mean is unknown. However, both N1 and N2 are greater and equal to 30. Then we can replace the population mean with the sorry, this is not population. The variance of the population. Then we replace the variance of the population with variance of sample. So means sigma replaced by standard by the variance of the sample. S squared. So S1 squared, S2 squared. So differ by here. Case D, population variance is unknown and we assume to be equal. And then both N1 and N2 are less than 30. So in this case, we need to find the pool, variance, the poolet estimated variance SP squared using this formula, which is N1 minus 1 times the S1 squared plus N2 minus 1 times S2 squared divided by N1 plus N2 minus 2. Mean both population variance are unknown but sigma, but they are equal but unknown. Mean the sigma 1 squared equal to sigma 2 squared, but their value are unknown. Then we calculate the poolet variance of the sample, Then basically mean the S1 squared we replace by the SP squared. So SP squared. So we factor factor out the SP squared, and then take out of the square root become the SP outside. And since both sample size are less than 30, we use the T distribution or the t-test. Case E and F, both population variance are known and assumed to be not equal. Then case E, both sample size are equal and less than 30. Okay, and then F, both sample size not equal but less than 30. So actually the general formula will be like case F, right? Case F mean the case F where once the sample size less than 30, we use a t-test and t-distribution, t-test and t-distribution. Okay, if unknown assumed to be not equal but both sample size are greater than 30, then the t-test is replaced by z-test. So the same formula here. Okay, however, if z-test, okay, we no need to find the degree of freedom, But if we use a t-test, we need to find the degree of freedom. Degree of freedom for case F, you have to calculate using this formula, where population variance assumed to be not equal. Okay, we need to calculate nu using this formula. Okay, and then if even though population variance are known to be not equal, but if both sample size are equal, then the nu, okay, degree of freedom is calculated using 2n minus 2. So mean, okay, E and F differ as the nu here. A way to get the nu, both using t-test. Okay, the hints here, sample size less than 30, we use a t-test. However, accept this case because population variance is known. Population variance is known. Even though sample size less than 30, we use the z-test because the population variance is known. And then another case, okay, even though population variance is unknown, but both sample size are greater than 30, we replace the sigma 1 squared and mean the population variance with the with the sample variance. In the third case, population variance unknown but to be equal. So it's actually like z-test because replaced by t-test because sample size are less than 30, and then actually based on this formula, once unknown and the population variance assumed to be equal, you need to calculate the Poulet variance, Poulet variance of the sample, this one. And the nu is n1 plus n2 minus 2. Mean this, this one, if we refer to here, replace a z-test by t-test, s1 squared and s2 squared actually equal to sp squared. Okay, and then if sample size same, but however the population variance assumed to be not equal, here, this one is assumed to be equal. Assumed to be equal, use a Poulet or calculate sp squared. Not equal, population variance are not equal, sample size equal, then basically you use back this formula, n1 equal to n2, nu is 2n minus 2, population variance not equal, both sample size less than 30, general formula here, just a nu need to calculate using this formula. Okay, now let's look at example number 4 because we continue from the previous hypothesis testing for single mean. 3 example, now example 4. And Moite placement test was given to 2 classes of 40 and 50 students respectively. In the first class, the mean grade was 74 with a standard deviation of 8. So both sample size are greater than 30. hence we'll use a Z test. Z test. The mean grade was 74 with standard deviation of 8. This is case B. Should be case B. Is it case B? It's a AB case C, where the populations K variant are unknown, case C. In the second class, the mean grade was 78 with standard deviation of 7. Is there a significant difference between the performance of the two classes at 5% level of significance? Assume the two population variants are equal. Okay, this one are equal. Okay, but here, both sample size greater than 30, we have a standard deviation only. Greater than 30. Greater than 30. Population variant is unknown, so it's case C. Case C. If you use here, assume to be equal, but this is the case, both sample size less than 30. So you use a case C formula. Here. Both sample size greater 30, sigma squared unknown, and then equal. We use a case C. Then you put out all the information. Step 1, okay. Write down the null and the alternative hypothesis. Okay. Is there any difference? Okay. Is there a significant difference between the performance of two classes? So is it mu1 equal to mu2? Is it mu1 equal to mu2? So that's what we asking. The claim at the null hypothesis. 5% level of significance, okay? Then the alpha is 0.005. However, the alternative hypothesis, there's no, okay, mu1 equal to mu2 versus mu1 not equal to mu2 here. The claim here, mu1 not equal to mu2. So it's two-tier because the alternative mu1 not equal mu2. So it's a two-tier test. Then put up all the information, and 140 and 250. Yeah. Okay. Mean bar, sample mean 1 74, sample mean 2 78. 74 versus 78. Standard deviation of sample 1 8, standard deviation of sample 2 7. 8 versus 7 here. 8 versus 7. Because the two-tier test, alpha over 2, alpha 0.05, alpha over 2 0.025. Okay, and the Z critical, okay, I will get this value. Okay, Z. So we use the table 4 because the Z distribution alpha is 0.025. 0.025. So the Z critical 1.96. Correct. 1.96 because two-tier, that's why plus minus 1.96. Then we calculate using the KC formula, calculate the Z test equal to the bar x1 minus bar x2. So put out bar x1, 74 minus 78, mu1 minus mu2, mu1 equal to mu2 or mu1 minus mu2 equal to 0, divided by the sigma of the S1 squared x squared, and 1 is 40, s2 squared 7 squared, and 2 50. If you calculate it, you get negative 2.4903. Okay, let me show my calculator. Okay, we look back the slide here. We calculate the z test here. You got 74 minus 78. So if you want to calculate minus 4, and then divide by the square root of x squared. Okay, so x squared divide 40 plus, okay, you got the 7 squared divide, okay, 50. Got negative 2.4903. Okay, negative 4, okay, 2.4903. And then here, so the step 4, okay, the decision rule, since the z test negative 2.4903, okay, is lesser than negative, okay, 1.96, lesser than negative, okay, z critical, which is negative 1.96, fall in the rejection region. Thus we reject the null hypothesis. Okay, means if you go to draw, mean the sorry, the like this. Okay, this is negative 1.9, 1.96 here. This is a rejection region, and then this value negative 2.43 something here fall in this region. That's why we reject the null hypothesis testing. Then step 5 is making the conclusion. Hence, okay, hence at alpha equal to 0.05, okay, at mean the alpha equal to 0.05, there is enough, okay, evidence that there is a significant difference, because we reject this one. There's enough, okay, evidence there's a significant difference between the performance of two classes. Okay, so means so to test a hypothesis testing between two means still the same 5 steps. Step 1, write down your null and the alternative hypothesis. Step 1, okay, write down all the information and their decision rules here. So if the value fall in rejection region, then we reject. Okay. Step 3, calculate the z test or the t test. Step 4, okay, reject or not reject, do not reject. Step 5, okay, the conclusion. Okay, and then with this, okay, thank you for your attention.